Hello, darkness, my old friend. I've come to talk with you again.
As we all know, the COVID-19 pandemic has affected our lives in various aspects. As an engineering student, this caused delays in my academic year due to the unavailability of measuring equipment to complete practical assignments. My solution to this problem is to build a low-cost oscilloscope. The oscilloscope is ideal for electrical engineering students that need to complete practical assignments but do not have access to laboratories or measuring equipment. Some of the benefits to the solution includes its cost to produce, which is less than R1,000. It is portable and only requires a laptop to function. This makes it ideal for power outages. It has a high voltage range up to 600 volts and can measure frequencies up to 50 kHz sinusoidal and 40 kHz square wave. This makes it ideal for power electronics, as power electronics mostly deals with mains voltage, which is 230 volts RMS at 50 Hz. It is also weather resistant and is therefore protected against dust and rain. The user interface is friendly and the sampling frequency can be adjusted. To use the system, we start by connecting to the computer. Thereafter, we need to connect the oscilloscope probe to the mains voltage. Take caution that this is mains voltage, so ensure that the power is off before measuring. After the oscilloscope probe has been connected to the point of measurement, the user must specify a sample frequency. For this demonstration, the sample frequency that will be used is 10 kHz. When changing this value, the auto reload register value will be automatically changed. This also updates the sample time in seconds that the system uses to plot the signal. This auto reload register value must be entered into the program software, as seen on screen at the moment. Once the value has been updated in the program for the auto reload register, we require a serial monitor program, in this case Hercules, to monitor the serial port. Ensure that all the specified values is correct for the serial port. In this case, we use COM port 3 with a baud rate of 150,200. The size of the data is 8 bits and there is no parity bit. Open the serial port and send to the serial port 1. After 1 is sent to the serial port, a series of 256 data values is sent to the computer. Copy these values and use it in our Excel spreadsheet. Paste these values in the digital sample section of the Excel spreadsheet. This then plots the signal as measured by the oscilloscope. We can then use this data to get a series of parameters of the signal. For instance, the maximum value, the minimum value, the peak-to-peak value, the RMS value, and even the frequency. A Fourier analysis of the data can also be computed. As seen in the graph below, the Fourier analysis is completed. If we zoom into the data, or to the graph, we can see that the frequency of this signal is approximately at 50 Hz, which is as expected for mains voltage.